Okay, good morning class, and we're on to mathematics for grade 10, and this is the MAMO experience. We've tried as much as possible to break maths into algebra, into arithmetic, and into geometry. The vision is that for every week of learning, we help you to more like relate with these aspects every week, so that you're able to see why a particular topic from an aspect of maths would relate well with another topic from another aspect of mathematics. We'll be looking at geometry today, and we'll be looking at an aspect of geometry called mensuration. And under mensuration, we'll be looking at circle and other related shapes. But let's have a little bit of introduction to what we will be talking about. When we talk about geometry, essentially we're talking about three key aspects of geometry. We look at geometry from the aspect of formal geometry, we look at geometry from the aspect of mensuration, and we look at geometry from the aspect of constructions. When we talk about formal geometry, what comes to mind is the matter of deductive reasonings. When we look at geometry from the matter of mensuration, what comes to our mind is length, or let's put in perspective, perimeter, area, and volume. And when we look at geometry from the matter of construction, what comes to our mind is the matter of trying to use a ruler, pair of compass, and other drawing devices to produce or validate assumptions from formal geometry. Okay, so these are the three areas we would consider when we talk about geometry. There's also another area I have added in handling grade 10 work, and that has to do with trigonometry. But technically, we don't add trigonometry to this aspect of geometry, so I wouldn't add that to this one. I will keep that out. But talking about geometry, although some writers will argue that trigonometry will come more under formal geometry, because a lot of the work there are more deductive reasoning or the likes. Some will argue that it comes under algebra. True, but trigonometry for me, I will treat more under formal geometry. But as three broad areas I will consider when looking at geometry, I will look at formal geometry, mensuration, and word construction. So today, we're focusing on mensuration. So what is mensuration? Mensuration essentially means to measure. And there are three ways you measure. You either measure with relation to length, you measure with relation to area, or you measure with relation to what? Volume. So let's put that in perspective. So when we talk about length, we're talking about things that are usually in one dimension. And it will interest you to note that when we talk about perimeter also comes under measurement of what? Length, as it were. Now, we talk about perimeter again and area. Essentially, this will come under 2D, which we call plane shapes. Plane what? Shapes. There are writers who would argue that perimeter don't come under length, and I, to a large extent, I agree with them, because the argument there would be that when we talk about perimeter, essentially we are talking about a shape. What is perimeter? Lengthwise, a plane figure. lengthwise a plane figure. Then we also have what is called surface area, total surface area, volume, all giving you something we call 3D and essentially solid shapes. So when we talk about mensuration, it doesn't go more than this. Either we're considering length, perimeter, area, surface area, total surface area, volume. One-dimensional, two-dimensional, or what? Solid shapes, or what we call three-dimensional. But remember that our focus today is not to go into those areas. We want to focus essentially on circle and what? Related shape. And that's what we're going into right away. Alright, we have a circle here, and I've drawn another circle here. And the first objective will be to try to name the parts of a circle. So by way of this class, we're going to try to name 12 parts. That's if you have to 12 parts of the circle. So we'll try to name 12 parts of a circle. So here we have on the board parts of a circle. We have radius, we have circumference, we have diameter, we have segment, we have quadrant, we have sector, we have chord, we have center of a circle, or sometimes some books will just call it center. We have the arc, we have the tangent, we have the semicircle. Our task now is to try to identify all of these on the diagrams we have on the board. So I'm going to be a little creative with the use of my diagrams here. I'll try to use one to show lines, those that are lines, and I'll try to use one to show those that are shapes. Okay, so in no particular order, this is what we call the center. So I'll call it O, and that means O is equal to the center of circle. Then this part outside is what is called the circumference. It's important you are able to identify and label them correctly. This part round it is called the circumference. Another name for circumference is the perimeter. So circumference refers to a special name given to the perimeter of a circle. So the perimeter of a circle is called the circumference. Right? Now, we have what is called radius. So this is radius. And from this radius, radii, we can have what is called arc. So this portion, a part or a portion of the circumference is called the arc. So if you understand the diagram we are drawing on the board, it becomes very easy to make any definition. So this is the arc. So maybe by way of, we should be thinking what we've done. We've done radius, we've done circumference. Now let's look at diameter. A diameter, so this one from here to here, we're going to write it like that. It's called the diameter. A diameter is a line that passes through the center of the circle while touching 2 points on the circumference. A diameter is a straight line passing through the center of the circle and touching opposite ends of the circumference. It's very important to take note of that. Now, having talked about a diameter, we can easily talk about a chord. A chord is a special, or rather, a chord is a line that touches opposite sides of the circumference but does not pass through the center. So some modern writers will say that a diameter is a special chord. And it's important you pay attention to the relationship between the diameter and the chord, because sometime later I'm going to give you a formula that you may not see in any textbook. The diameter is equal to the 2 times 2 arrow what sine theta over 2. I'm right with that. We'll talk about that much later. We'll try to explain that formula much later. I'm not very sure that I've gotten it right, but we will be able to derive that. What it means is that a diameter is a chord is a decreasing diameter. So that's another way you can define a chord. A chord is a decreasing diameter. So if this is 180 degrees, what you have is that this will be equal to this, because 180 will now be what? 180 divided by 2 becomes what? 90. What is sine 90 from your trigonometry? Is 1. So this is equal to 2 arrow. So this is, did I get that right? Sorry. A chord, length of chord. Yes, the length of chord is equal to 2 arrow sine theta over 2, which means that this will be equal to d sine theta over 2. So we say that a diameter is a special, or rather diameter, yes, is a special type of chord that passes through the center of the circle. These are just arguments. When we come into some problems, you appreciate what we have done. So let's see, we have talked about diameter, we've talked about chord, we talked about the center, we talked about an arc. I'm right. Now, we've not talked about a tangent. What's a tangent? A tangent is a line that just touches any point on the circumference of the circle. So this is what is called a tangent. And what a tangent essentially does is that it forms 90 degrees with the radius of the circle. So from this radius to this tangent, the angle here must be what? 90 degrees. So this is tangent, this is radius. So we're taking care of that. The next thing we want to talk about is the semicircle. Now, the semicircle is a shape. We've talked about things that are lines in nature. Now we want to talk about shapes. The semicircle, if this is center, and I do this, and I shade this region, what I'm going to get here is called the semicircle. The semicircle is a shape, because much later we're going to look at specific shapes that are circular in nature, and we'll be able to describe why they are. Now, why is a semicircle a shape? A semicircle is a shape bounded by what? The diameter and the arc. This is an arc. This is a diameter. So this region becomes what? The semicircle. Alright, maybe by way of treating this better, we may have to draw one more diagram. We need to draw one more diagram. So let's draw one more diagram. And then use that diagram to explain the concept of segment and sector. Now, look at this. This part here bounded by an arc, let me call here AB, and a chord AB. This is what we call a segment. I'm going to give us more technical details later, but I want to keep the narrative as simple as possible. Now, watch carefully. This part, now watch carefully, see what I'm going to do. That I have shaded in this manner. The whole of this region I shaded in this manner is what we call a sector. Why is it a sector? It is bounded by this one radius, this is another radius, and this is an arc. So a sector is bounded by an arc and two radii. That's why this is called a sector. So if you look at this carefully, you discover that if I now want to form a sector, rather a segment from a sector, all I need to do is to cut out this part from it, this triangle from it. Once I cut out this triangle, what I'll be left with, remember this is center O, what I'll be left with will be what? A segment. So this is just giving us, I think we're taking care of everything. This is just giving us a general summary. Of course, a quadrant is just a quarter. A quadrant is a quarter of a circle. And technically, a quadrant is also a sector. Take note of that. A semicircle and a quadrant are sectors. A sector tells us how much to which an angle is opened. The shape formed by the opening of the angle from the center of the circle. So the extent to which it is open will tell us the type of sector. If it opens to 90 degrees, what we have is a quadrant. If it opens to 180 degrees, what we have is a semicircle. So that gives us an overview of circles, the parts of a circle, and the shapes we can have. And if you are very observant, you would have noticed that there are three major shapes or four major shapes you have that are circle related. So, circle related shapes. The first one is a circle. The first one is a circle. The next one is a segment. And finally, the other one is a sector. So there are three major shapes you can consider when you talk about a circle. The circle, the segment, and the sector. And these three shapes, we can actually find their perimeter and their area. And that's the objective, to be able to look for their perimeter and to look for their area. Alright. Okay, different writers have different take on this matter of mensuration for circles and their related shapes. My approach will be to take each shape and tell you how to look for the perimeter and the area. We're taking the circle first. Now, for a circle, we know that the perimeter is also the circumference, is that not? So if the perimeter, which is the technical way of describing the circumference of a circle, is this, it means that the circumference of a circle will be equal to what? 2 pi r, or we can say pi d. Because we know that the diameter is equal to 2 times the radius. There's an experiment you can perform to prove that pi is equal to what? 22/7. There is an experiment you can perform to show that pi is equal to what? 22/7. And this experiment is very simple. Get a sheet of paper, draw a circle. Once you've drawn the circle, measure the diameter of that circle. Keep the measurement. Take a thread, start from a point of the circle, and try to move the thread round, gradually, round the circle. Once you've done that, cut the end of the thread and stretch it out. Use your ruler to measure. If you take the measurements of the circumference divided by the diameter, you would approximately get 22/7. The closer you get to 22/7 tells how accurate your measurement is. It's practical. So the circumference, or rather the pi, which we call a constant, is obtained by knowing the circumference of the circle and dividing it by the diameter. But we expect that you have passed that stage, so we wouldn't worry so much about the understanding of this idea. So we have the circumference of a circle being 2 pi r, and the diameter and the circumference also defined in terms of the diameter to be what? Pi d. It's very important you pay close attention to this idea, because this will be the idea that will help us to develop other formula for other aspects of this discussion. So that's for the circumference of the circle, or the perimeter of the circle. Now, what about the area? The area of a circle is given as pi r squared. If diameter is equal to 2r, by the knowledge of your what do you call it, by the knowledge of your change of subject or formula which you have done, 2r will be equal to d and r will be equal to d over 2. So we can place this one where we have r, and then the area, which we call capital letter A with subscript c, meaning area of a circle, will be equal to what? Pi times what? D over 2 all squared, which will be pi d squared over 4. It's important to take note of this. If you have to memorize this, you need to memorize this, because this will form the basis for you understanding every other thing we're going to talk about. Alright, this is simple and fundamental enough. We will now use these ideas to drive the formula for a sector, and perhaps formula for the area of a segment. Okay, so the next related shape we'll look at is a sector. Now, a few things we need to take note of when we talk about the sector. You discover that our video today seems to focus more on basic description of things we need to know, and our subsequent video will try to focus on the mathematical implication, how we now apply these ideas to solving problems. Now, every time you divide a circle using your radius, what you're going to obtain will be sectors, especially when you divide with respect to the center of the circle. Now, whenever you divide a circle, what you're going to get will be two sectors, a minor and a major. This is with respect to the area it is covering. But with respect to the circumference, you're going to have what is called a major arc and what? A minor arc. So, what is the basic idea that differentiates a major arc from a minor arc, or a major sector from a minor sector? Very simple. If theta is less than 180 degrees, all arcs and sectors formed are minor. So if theta is less than 180 degrees, all arcs and sectors formed are what? Minors. Either you're having a minor sector or a minor arc. Now, but if theta, let me use the diagram. Using the diagram on the board, if alpha is greater than 180 degrees, all arcs and sectors will be major. So the arcs and the sectors form whenever the angle, we just say theta, we just say alpha. But the key point here is that if it is greater than 180, it becomes a major one. Note that theta or alpha are treated as angles subtended at the center of the circle, sector or arc. Take note of that. Theta refers to the angle subtended at the center of the circle, sector or arc. Take note of that. That definition is so important. Anytime you see theta and it's in this manner, or you see alpha, they refer to the angle subtended at the center. It is this angle that brings about the sector, and the size at which the angle opens up will determine the kind of sector or arc you're going to have. I have here with me a pair of dividers, and you discover that if I open this divider, what you notice is that the angle inside is increasing, and if you could use your imagination a little, you discover that the circle it will form, or the arc being formed, will also increase to the measure by which I'm opening this one up. As a little extension, if you remember when you were treating pie charts in statistics, you will discover that the angle formed at the center will determine the extent to which the arc you will draw or the sector you will draw would be. So it is this angle that is critical to the size of the sector or the arc. Let's take note of that. The size of the angle, which we have called the angle subtended at the center, is critical to the length of the arc and the area of the sector so formed. Take note of that. So if the angle is less than 180 degrees, it is a minor. If the angle subtended at the center is bigger than 180 degrees, it will be a major. Sometimes in question, they will not tell you, they just tell you the angle subtended at the center is 80 degrees. Find the length of the major arc. You discover here that they are trying to confuse you. What you need to do and to remember from your knowledge of formal geometry is that the angle at the center is what? 360 degrees. So the angle they have given to you, which is 80, becomes what? The minor. Becomes a minor arc angle. So what you need to do to find the major arc will now be to remove 80 from 360, and that will be what? 200 and what? 200 and what? 40 or thereabout. So it is the 240 you will now use to solve your problem. When we come to solving problems, you will see this play out. So let's now get relevant formulas to solve this. Now, the length of arc, any arc at all, the length of arc, if the angle subtended at center is theta, will be L small letter a, meaning length of arc, equal to a portion of the circle we said that the length of the arc is a portion of the circumference of the circle. So the length of arc refers to a portion of the circle. So let me put it in English. So this is what? A part of a part of the circumference of a circle. So this theta over 360 means a part of times what? The circumference of the circle. So that gives you the length of the arc of the length of the arc of the circle. Now, what will happen to the perimeter? Perimeter of the sector. The perimeter of the sector will be length of arc plus. Look at this sector. It has a length of arc and it also has with it 2 radii. I seen it. This one plus this one. It is this arrangement that make up this shape. It is this arrangement that make up this shape. So it means that it will be what? Plus what? 2 radii. So when you have this, if you want to put this mathematically now, the perimeter P of a sector PS, let me call it PS, will be equal to a portion of the circumference plus 2 radii. So this becomes the perimeter of the what? Sector. So finally, whether it is a major or a minor now will be dependent on what theta is. If theta is above 180, the sector is a major one. If theta is below 180, the sector is a minor one. So with that, we can also try to look for the area of a sector. Now remember that I had said that the type of area you look for is a function of the angle given to you. So I will not bother myself so much about whether it is minor or major. When we start solving problems, we can now narrow out. Okay, so with that said, the area of a sector will be what? A portion of the circle. That's what the area of a sector is, a portion of the circle. So what's a portion? Theta over 360 times what? A portion of the, let's call it area of a circle, so that we're very clear about what we are saying. And this will be a portion, is always in algebra, rather in geometry, a portion is called theta over 360 of a circle pi r squared. And this is the formula. So I can call this to be AS equal to theta over 360 times pi r squared. So we've been able to look at 2 key shapes today relating to the circle. We have one more to go. And once we are done with that last shape, we will go straight ahead to begin to solve mathematical problems. It's important that you watch this video over and over again so that you can gain understanding and mastery of some of the ideas. Some of these ideas, you will find them in conventional math textbooks because some of them have come as a result of years of teaching and practicing mathematical formulas and using them in problem solving. So this is the size of our package today. I'm trusting you have gained something. And my motto will always be interested about what you're doing and keep practicing. So this is when Mamu with Jarvis will sign out from our end and trust that you keep up the mathematics experience. Thank you very much.